Good evening to one and all, and welcome to NPTEL classes. I am here to solve Chemistry Class 12th NCERT problem 2.23 and 2.24. Both these problems are conceptual problems and are based on intermolecular forces of attraction between two components in solution. Let me read problem 2.23. Problem 2.23 is suggest the most important type of intermolecular attractive interaction in the following pairs. We have normal hexane and normal octane as one pair. Likewise, we have three other pairs of chemicals. Now we have to identify most important type of intermolecular attractive interaction in these pairs. Coming first to normal hexane and normal octane. Both these are non-polar molecules, organic molecules. In fact, both these are hydrocarbons consisting of carbon-hydrogen chains, carbon chains formed of carbon linked to hydrogen atoms. And we know electronegativity difference between carbon and hydrogen bond is not that much to make the bond polar. So considering these points, normal hexane and normal octane are both non-polar molecules, and interaction between non-polar molecules is always van der Waals forces of attraction. Van der Waals forces of attraction. Coming to next part, that is sodium perchlorate and water. Sodium perchlorate is an ionic compound consisting of sodium cation and perchlorate anion, and in water it will undergo ionization to form sodium cation and perchlorate ion. So there is presence of, so its fate in water is that it exists in form of ions. And water has two OH bonds. Both these bonds are polar because of appreciable electronegativity difference between oxygen and hydrogen. Both these bonds will have their own bond moments. As such, water has a definite value of dipole moment and represents a polar molecule. Therefore, nature of interaction will be ion. I said that fate of sodium perchlorate in water is that it exists in form of ion, and water, because of electronegativity difference between oxygen and hydrogen, will constitute has a appreciable value of dipole moment, probably 1.84 dB, and it represents a dipole. So nature of interaction is ion dipole interaction, ion dipole attractive interaction. Coming to third part, methanol and acetone. Both these are organic molecules. In addition to carbon and hydrogen, there is presence of OH bond in methanol, which is polar, and there is presence of carbon oxygen bond in acetone. Chemical composition of acetone is this. CH3, C double bond O, CH3. There is inorganic, there is non-polar part comprising of carbon and hydrogen, but there is also polar part comprising of carbon and oxygen. Carbon bonded to oxygen by means of double bond. Here in this bond, in bond between oxygen and carbon, there is electronegativity difference between oxygen and carbon, with oxygen more electronegative and carbon less electronegative. So this bond will has polarity, it is polar, it will form a dipole. Methanol also has OH bond which is polar and will constitute a dipole. So nature of attractive interaction in this pair of liquids, methanol and acetone, will be dipole attraction. Now coming to last part, acetonitrile. Acetonitrile has composition CH3CN. One chemical is acetonitrile having composition CH3CN, and other chemical is acetone having composition CH3C double bond O CH3. Now look, in acetonitrile there is carbon and hydrogen part which is non-polar part, but despite that there is carbon nitrogen bond, and because of electronegativity difference between nitrogen which is more electronegative than carbon, this cyanide functional group has polarity. This cyanide functional group will constitute a dipole, and in acetone already I said that it has polar CO bond, because of which it will again constitute dipole. So here again nature of attractive interaction is dipole attraction. Normal hexane and normal octane, both are hydrocarbons. In both there is non-polar carbon hydrogen backbone, and they represent non-polar molecules, and interaction between these two is van der Waals force of attraction. Weakest force of attraction, that will be van der Waals force of attraction. Sodium perchlorate and water. In fate of sodium perchlorate in water is that it exists in form of ion. Water has permanent dipole moment 1.84, so it is a dipole. Therefore between sodium perchlorate ion and water, nature of attractive interaction is ion dipole interaction. Methanol and acetone. In methanol there is OH. Methanol acts as dipole because of presence of polar OH bond. Acetone acts as dipole because of presence of polar CO bond. So nature of attractive interaction is dipole attraction. Acetonitrile is polar because of acetonitrile behaves as dipole because of polar CN bond. Acetone behaves as dipole because of presence of C double bond O. Hence nature of interaction again here is dipole interaction. Now coming to problem 2.24. Let me read this problem one time. Increasing order of solubility in normal octane is. We are given four solute molecules, and nature of these four solute molecules is different. First solute for us is cyclohexane. In second case solute, nature of solute is potassium chloride. In third case nature of solute is methanol. In fourth case nature of solute is acetonitrile CH3CN. Solvent is same for these 3-4 solutes, differing in their nature. Solvent is same for these four: normal octane, normal octane, normal octane, and normal octane. So basically these are four solutions. In these four solutions nature of solvent is same, normal octane, but nature of solute in them is different: cyclohexane, potassium chloride, methanol, and acetonitrile. Now we have to make increasing order of solubility. We have to arrange them in increasing order of their solubility. We have to arrange cyclohexane, potassium chloride, methanol, acetonitrile in increasing order of their solubility in normal octane. For that, idea is first we will try to identify nature of our solvent and nature of solute. Coming first to solvent, because solvent is same for same. Coming first solvent, normal octane is hydrocarbon made up of carbon and hydrogen atoms. So it only has carbon chain with carbon linked to hydrogen atoms, and we know electronegativity difference between carbon and hydrogen is very less. So this carbon hydrogen backbone or carbon hydrogen chain we will consider as non-polar. So my point is basically that normal octane is hydrocarbon and its nature is non-polar. It is non-polar in nature because there is only carbon hydrogen bond with meager electronegativity difference between carbon and hydrogen. Now coming to first cyclohexane. Cyclohexane, it is also hydrocarbon, alicyclic hydrocarbon. It is cyclic compound. In this cyclic compound there are 6 carbon atoms in form of ring, and each carbon atom is bonded to 2 hydrogen atoms in order to satisfy its tetravalency, and this results in formation of cyclohexane. So my point is cyclohexane is again a hydrocarbon with cyclic chain formed of carbon and hydrogen only. So it again will represent its nature again is non-polar. It is again non-polar in nature. Now cyclohexane is non-polar, normal octane is non-polar. Here interaction is between 2 non-polar molecules, and this guiding principle here is like dissolves like. Non-polar solute prefers non-polar solvent, polar solute prefers polar solvent. Based on this guiding principle, I will say that cyclohexane will be readily soluble in normal octane, readily soluble. It will have maximum solubility because normal hexane is non-polar, normal octane is also non-polar. Now coming to Kcl, potassium chloride, it is ionic compound. It is ionic compound made up of ions, and ionic compounds are polar. They have polarity, charge separation, positive on cation, negative on anion. Normal octane for us is non-polar. So here interaction is between polar and non-polar. Coming to because unlike molecules are in contact, interaction is between molecules of different nature, one polar, other non-polar. Here solubility will be less. Solubility of Kcl in normal octane will be least. Coming to next, methanol and normal octane. Because of presence of this polar OH bond, methanol behaves as dipole. Methanol behaves as dipole. It is polar in nature. So here again polar, non-polar. Acetonitrile, because of presence of cyanide group, functional group, it is polar. Normal octane, it is non-polar. Again interaction is between polar and non-polar. Now we are in a fix because there are 3 interactions between polar, non-polar, polar, non-polar, polar, non-polar, but magnitude of their interaction will be different. Least polar on basis of electronegativity difference, I can say that least polar is CN bond, or if I compare CN bond with OH bond, I will say CN bond is less polar than OH bond, because electronegativity difference between carbon and nitrogen is less than between oxygen and hydrogen. So here polarity I will mark 1. It is polar and to the magnitude of 1. This is polar to the magnitude of 2. This is polar and in fact ionic. Its polarity will be highest, 3. Now I have to arrange these in increasing order of their solubility in normal octane. Normal octane is non-polar, it will prefer non-polar, and which is highest non-polar among these? Cyclohexane, followed by acetonitrile, followed by methanol, followed by Kcl. So least soluble will be Kcl. Kcl will be least soluble in normal octane, followed by methanol, followed by acetonitrile, CH3CN, and maximum solubility will be shown by cyclohexane. Maximum solubility in normal octane, if our solvent is normal octane non-polar, maximum solubility will be shown by cyclohexane, followed by acetonitrile, followed by methanol, followed by Kcl. Least soluble will be Kcl. But if we will change nature of solvent from normal octane to water, which is polar, then this order will get reversed. Maximum solubility in water will show Kcl, followed by methanol, followed by acetonitrile, and least solubility will be shown by cyclohexane. This way, by identifying nature of solute and solvent here, and by identifying nature of solute and solvent here, we could answer problem 2.23 and we could solve problem 2.24. This is solution of problem 2.23, where we had to identify nature of attractive interaction between two molecules, and this is solution of problem 2.24, where we had to arrange these solute molecules in increasing order of their solubility in normal octane. Class 12 students, be blessed. This is what I have got for you today. Basically, these two problems are based on concept of solubility of solids in liquids, solubility of liquids in liquids, and solubility of gases in liquids. Take good care of yourself. See you on Tuesday, as Monday is reserved for class 11 students. Allah Hafiz.